So here we have a couple of extra examples using exponents in sequences, and I'm going to specify things we can do on the calculator. So here we have a problem where we want to find the smallest term in the sequence 3, 6, 12, 24, 48, etc., which is greater than the number 48,000. So the first thing I notice is that this is a geometric sequence because we're multiplying by 2 each time, and so remembering the formula for a geometric sequence, g sub n is equal to 3, which is the first term, times 2, which is the common ratio, raised to the n minus 1. So this is the formula that will allow us to find any term along the way. So the first method I'm going to show you is how to use the calculator to get this quickly. So we're going to hit the y equals button, and that's going to take us to the regular menu for plugging in functions. And under y1, we're going to type in this equation, 3 times 2 to the, and then I'm going to use x for the variable, x minus 1. So either old operating system, y1 equals 3 star 2 exponent, parentheses x minus 1, or new operating system 3 star 2, and then you hit the exponent button and it gives you the box for the exponent and you fill in the x minus 1. So what we're going to do next is we're going to use a table of values. So in order to do that, we want to first make sure that our table of values is using the right type of input values. So we're going to hit the second button and then table set, which is second, and then it's right above the window button, table set. So that should bring up a menu that looks something like this. It'll say table setup, it'll say table start, and we want that number to be 0. It might default to that. And then delta table, and we want that number to be 1. So the first number in our table in the input is going to be 0, and then it's going to change those numbers by 1. So it'll go 0, 1, 2, 3, 4, etc. Keep adding 1 each time to our table. And the other two things are really not important. Keep them on auto, it's perfectly fine. So now to get the table, we're going to do second table, which is second, and then graph. So it's similar to trying to just get the graph. In this case, we're trying to get a table of values that would have been on the graph. So second table. So now the calculator should show us something like this. It has a table of values with an x column and a y1 column. It's got some blank columns over here too. And it should have 0, 1.5, 1, 3, 2, 6, etc. And the 3, 6, 12, 24, etc. These numbers should be the ones down the y1 under the first term, second term, third term, etc. The problem is it stops at 6, or at least on my calculator stops at 6, and we need to keep going. Now remember, we're trying to get the first value, which is greater than 48,000. So we need to go down this list until we reach a number in the y column that is bigger than 48,000. So we're going to hit the down arrow button a few times and see what happens. Now after scrolling down enough, I get to this part of the list and I notice that there is the very first number that is bigger than 48,000. So the 14th term was not quite big enough, 24,576, and the 15th term is 49,152, and the 16th term is, of course, a lot bigger than that. So I'm in my work, I'm going to list the two values that are one right before it reached 48,000 and then one right after it passed 48,000. So the 14th term and the 15th term to quote-unquote show my work. And then the question said, what is the smallest term? Not which term is it? Not that which, that is the 15th term, but what is the actual value of that term? And so I answer my question by saying the smallest such term is 49,152. One quick point I want to make, though, is that this process is only useful because we're dealing with a sequence where the input values have to be integers, and therefore a table of values where the input is integers makes the most sense. If this was a function with x instead of n, and you were talking about real numbers, then a graph would have been a better way to do this. So now we're going to do the same problem again, but this time we're going to use logs instead. So again, we want the smallest term in the sequence that is greater than 48,000. So this is the explicit formula for the sequence since it's geometric. And we're going to set it greater than 48,000. But of course, we're going to solve it as if it was an equal to. So we have 3 times 2 to the n minus 1 equals 48,000. And then we divide by 3, so 2 to the n minus 1 equals 16,000. So I'm going to rewrite in its logarithmic equivalent. I'm going to use a change of base formula to evaluate the log base 2 of 16,000. And then I'm going to add 1 to both sides to isolate n. So we plug this into the calculator with the 1 plus, and I get 14.96, etc. So in order to guarantee that I'm going to exceed 48,000, given that these values keep increasing, I need to go to n equals 15. However, the question did not say what is the term number or how many terms. It wanted the first term or smallest term itself. So I'm going to plug the n equals 15 into the formula for the geometric sequence, so right there. And so the final answer is 49,152. So for this particular example, I think the log method was easier, but that was only because it was relatively straightforward to solve using logs. So I'm going to do an example where this method will not work. So in this example, we have two sequences, this sequence and this sequence, and we're trying to find the smallest n such that u sub n is greater than v sub n. Now this is going to be exponential, but this is not, but it still has the variable n in it, and so logs is going to fail. So instead, we have no choice but to use a table of values, or we could graph two functions and find the intersection, but because these numbers get very, very big, the table of values is going to be the safer way to do it, because we're dealing with sequences. So in my y equals, I'm going to type in these two functions. So y1 will be 3 to the x minus 1, and y2 will be 500 plus 1000x. So once again, we're going to hit the second table set button, second window, and then we're going to make sure that the table starts at 0 and delta table is 1. So it probably will not be at 0 because of the previous example that we did. We had to scroll down, so go back and start it at 0 again. So now we're going to do second table to get a table. So now the table will look something like this. It'll have x values, and if we've set it correctly, to start at 0 and go 1, 2, 3, etc. And then have y1 values and y2 values. The y1 came from the un, so those are the un values. And the y2 came from the vn, so those are the vn values. And again, remember, we're trying to find un greater than vn for the first time. So I just listed the first three and then the bottom. And so my sixth term for UN was 243 and for VN was 6,500. Clearly this number is not bigger than that number. So I'm going to scroll down using the down arrow a few times until I can get that pairing to work out correctly. So again, I scroll down a few times, and I now get a list that includes these values here. So the 9th UN value is too small, but the 10th UN value is bigger than the 10th VN value. So to show my work, I'm going to list U9 and V9, U10 and V10 to show that U9 was not big enough, but U10 is big enough. Now the question wanted the smallest n, so I need to say the smallest n is equal to 10 because that's what it wanted, not the actual values, although the actual values were required in order to show my work. So this particular problem was pretty much only solvable with a table or with a graph, but you look at the y values and the range on that graph would have been huge. It would have been a little tricky to make sure you can get the right window. Table doesn't care about the window. So that's the end of the lesson.